guys. Today we are doing section 1.5. It's the last section of the chapter. Often the last section of the chapter is an applications section where we try to use the skills that we've learned in the chapter and apply it to real situations. I'm not sure this one's great, but we're going to try a few problem solving, work on our problem solving skills. Before I do that, let's review square roots one more time real quickly. We have learned previously that the square root of a number might result in an answer that is either rational or irrational. Do you know the difference? The square root of a perfect square is a rational number, right? Like if I take the square root of 9, 9 is a perfect square, so when I take the square root of 9, I get a rational number. I get 3. Whereas, oops, I see I have a little typo here. The square root of a non-perfect square is an irrational number. Pay no attention to that R. It's not really there. For instance, if I try to take the square root of 10, I get a non-repeating, non-terminating decimal. So I can't give an exact answer. It would be about 3.1 if I approximated it, but it would not be exact, right? All right, here we go. These first set of problems are problems where you'll be given a mathematical expression and your job is to find values of the variables that make the expression either rational or irrational. I think it's important to pay attention to all of the directions, and there are a couple ways you can do this. You know, often in math, a good way to solve a problem is just by guessing and checking, seeing what makes sense. Or you might try to figure it out systematically, and I'm going to try to walk you through that kind of. Let's look at the example. It says, find values for x and y to make each statement true if possible. Assume that x and y are natural numbers less than 10 and x cannot equal y. Now these are 3 important points, and this is what I mean by making sure you read all the directions carefully. I am looking for 2 numbers. They've got to be natural numbers, and they've got to be less than 10. So my choices here are 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are natural numbers that are less than 10. And I cannot have x equal y. All right, so I am looking for the square root of x squared plus y squared to be a rational number. And 1 through 9 are the numbers I can choose from. Now I could just guess and check like this. I could start just putting numbers in for x and y, like I'm going to try 1 for x and 2 for y. 1 squared plus 2 squared. Let's see. That would give me 1 plus 4. That would give me the square root of 5. Is the square root of 5 rational or irrational? Well, 5's not a perfect square, so it's irrational. That is not the correct answer for x and y. I am looking for 2 numbers that give me a rational answer. I could try again just plugging numbers in, but let me try to walk you through how to do this systematically. Okay, again, these are the only numbers I can choose from, 1 through 9. And here's the thing. X squared, when I put a number in for x and I square it, I get a perfect square. And when I put a number in for y and I square it, I get a perfect square. So x squared is a perfect square, and y squared is a perfect square. And when I add those together, I want the square root to be rational. That means I want x squared plus y squared to be a perfect square. So when I take its square root, I get a rational number. Well, I want x squared plus y squared to be a perfect square. So x squared plus y squared needs to be let me walk you through this. When I square the x, I get a perfect square. So when I square x, I get one of these numbers. These are perfect squares, up to 9 being my biggest number I can put in for x. And when I square the y, I get a perfect square. So I also get one of these. But the thing is, when I add them together, I also have to get a perfect square because the square root is rational. And if the square root is rational, that means I'm taking the square root of a perfect square. So what I'm really looking for is two perfect squares that when you add them together, you also get a perfect square. Well, I could add 1 and 4 together, I get 5, but that's not a perfect square. What if I add 4 and 9 together? Let's see, that'd be 13. That's not a perfect square. I think I see it. If you add 9 and 16 together, you get 25, which is a perfect square. So that means if I made x equal 3, so that when I square it I get 9, and I made y equal 4, that should work. Let me test it. See, I get 3 squared plus 4 squared. That would be 9 plus 16, that would be the square root of 25, and the square root of 25 is a rational number. It's 5. I have found a value for x and y that works. X could equal 3, y could equal 4. There's a couple more numbers in there that when you add them together, you get a perfect square. Can you find them? .36 and 64 add up to 100, which is a perfect square. So I could have my x equal 6, and I could have my y equal 8, and that would also work. All right, that's a tough problem. But again, what we want you to practice is just thinking mathematically. Guess and check, or try to think about it systematically. All right, the next example is exactly like that one, except now I want x squared plus y squared, the square root of x squared plus y squared, to be irrational. Well, I think I already found that. I could have x equal 1, I could have y equal 2, and when I put them in, I get an irrational number. There are actually tons of choices for this one. Pretty much anything other than 3 and 4 or 6 and 8 would make the answer irrational. Let's go to the back. All right, now I'm going to look at a few real situations that we want to problem solve that involve square roots. All right, I think the important thing here is when you're given a situation, try to think about it by maybe drawing a diagram. I think diagrams help a lot. Or at least use any formulas you happen to know or were given in the problem. And then make a plan and try to solve it. Let me go through a couple examples. It says the area of a square patio is 90 square feet. How long is each side? Well, I could draw a picture of the patio. There's a square that's got an area of 90 square feet. And I know this one. I know the formula for the area of a square. The area of a square is equal to the side length squared. Well, I know the area is 90. So I need some number that when you square it, you get 90. That's just the square root of 90. Looks like each side of my patio will be about 9.5 feet. Again, 90 is not a perfect square, so when I take the square root, I get an irrational number, and I'm going to have to round it off. And I round it to the nearest tenth, about 9.5 feet for the length of each side of the patio. Isn't that weird that the length of the patio, you can't actually measure it? It's an irrational number. It's a number that goes on forever. At least you can't measure to an exact number. All right, the next example. I think I got this from watching CSI. The formula, V equals 2 times, it's a weird formula, 2 times the square root of 5 times L can be used to estimate the speed at which a vehicle is traveling, V. Now, V is a variable, and V stands for the speed that a vehicle is traveling. I think it stands for velocity. By measuring the length of the skid mark, L. So when a car is traveling, and it tries to come to a quick stop, like it's going to be in an accident, and a guy jams on the brakes and he makes skid marks, you can measure the velocity at which he was traveling by measuring the length of his skid marks, L. We're going to try to estimate the speed of a car that left skid marks that are 120 feet long. And we're going to round to the nearest tenth, it looks like. All right, so in this problem, I am given a formula. My job is just, can I use the formula to calculate what I need? Let's see. So there's my formula. I want to find the velocity, but I know the length of the skid marks. They're 120. So this would be 2 times the square root of 5 times 120. So first I would go inside the square root sign. That's like a grouping symbol, like parentheses, and I would do 5 times 120. So now I have 2 times the square root of 600. And the next thing I would do is I would find the square root of 600. The square root of 600 turns out to be about 24.49, and it keeps going. It's an irrational number. So now my answer is going to be an irrational number. And when I multiply 2 times this irrational number, I get 48.989, and it keeps going. Again, I just left the entire number on my calculator and multiplied it times 2. And so the velocity turns out to be about 49 miles per hour. The car was traveling about 49 miles per hour if it left skid marks that were 120 feet long. Got one more quick example I'm going to try to squeeze in, but it's not an easy example. I have a rope that is marking off a square plot of land. And it has an area of 6 feet. Is that rope long enough to mark off a circular area with a diameter of 3 feet? All right, so it sounds like I need to figure out the length of the rope that marks off the square and then see if that's long enough to mark off the circle. So let me start with the square. So if I know the area of the square, can I figure out the side length? Absolutely. And if I know the side length, can I figure out how long the rope is that goes all the way around the square? I think I can. So the side length is going to be the square root of 6. And since the square has 4 sides, then the rope is going to equal 4 times the square root of 6. So I type in the square root of 6 to my calculator and I multiply it by 4. And it's an irrational number, but it turns out to be about 9.8 feet. Let's go look at the circle. So I have a circle whose diameter is 3 feet. And I want to know if the rope is long enough to go all the way around the circle whose diameter is 3 feet. Well, all the way around the circle, that is called the circumference. And there's a formula for the circumference of a circle. It's pi times the diameter. So let me calculate the circumference of a circle, that's the distance around the circle, if the diameter is 3 feet. Looks like the circumference is 9.42 feet. And I have 9.8 feet of rope. So, yes, 9.8 feet of rope is enough. All right, you're going to try a few problem-solving problems on your own for homework. Good luck.